Hey everyone, how's it going? Today I'm bringing you guys the final video of this chapter 5 unit. And in this video, we are basically applying a little bit of what we've been learning the entire unit for chapter 5. But more so than that, we're actually applying a little bit more of what we learned yesterday or in the previous section from day 1 of 5.5. Okay, so in that we were looking a little bit at some real world scenarios that can be modeled using linear equations, but more specifically can be modeled using linear inequalities. Okay, and those have been able to we've been able to use in order to basically, like just like the title says, to identify some real world applications. Okay, so why don't we go ahead and get started right away? This next problem will actually be very similar to the ones we did in the day 1 video. So let's go ahead and make sure we still remember how to do that. So what does number 1 say? It says at Steak and Shake, 5 triple burgers and 4 orders of French fries cost 800. Ugh, not 800. $8.48. Sorry about that. I am spacing out over here. I don't know of any triple cheeseburgers or fries that could cost $800. But anyways, we also have that 6 triple burgers and 3 orders of French fries can cost $9.24. All right, it's asking find the prices of one. Let me get my highlighter here. Find the prices of one triple burger and one order of fries. So that's exactly what we're going to go ahead and use for our variables. My triple burger will be my x, my fries will be my y. So let's go ahead and write that down here on the side just to make sure we keep track of that. So price of triple burger and y will be price of fries. All right, we defined our variables. That was the first thing we need to do. Once we do that, if you guys remember from last time, we have to be able to identify the two equations that are being modeled here. So let's go ahead and take a look at the problem once again so we can identify those. So it says 5 triple burgers and 4 fries would cost $8.48. So right there we have our first equation. So we have 5x plus 4y equals $8.48. Okay, next scenario, we have that 6 triple burgers and 3 fries would cost $9.24. So yet again, we have a new equation. So plus 3y equals 9.24. Okay, so those are my two equations. Now I have to try to find one of these variables, and in order to do that, I can use any three of my original methods of solving systems of equations, which would be graphing, which obviously here I'm not going to do. I don't even have a graph. But I could do substitution, which in this case would be a little bit hard because there's nothing that already has y equals or x equals. I can get it to that point, of course, but that might take a little bit of work. Okay, so what I think I'm going to do is my final method, which in this case would be elimination. All right, and that one we have to identify if we can eliminate right off the bat the x's, which in this case we cannot because 5 plus 6 would be 11, so I can't eliminate those. And then my y's would be 4 plus 3, which would be 7. So again, those do not cancel each other out. In order for them to cancel, they have to be the same number, but exact opposites. So one of them has to be a positive, one of them has to be a negative. And that is why my next step is always to verify. On the x's, is one of them already positive, one of them negative? Nope. What about my y's? Is one of them positive, one negative? Nope, they're both positive. So the next step would be, let's look at the smaller of the two numbers. So this 5 is smaller than this 6. So I asked myself, can I turn that 5 into a 6 by multiplying it by anything? Well, no, I can't. Okay, well, too bad. Let's try the y's. which one's smaller from my 4 and my 3? Well, my 3 is smaller. Can I turn that 3 into a 4 by multiplying it by another whole number? Well, this one actually can't be done either. Okay, so we went through our entire checklist. We can't turn the smaller one into the bigger one, or rather, we can't turn the smaller one into the opposite of the bigger one. So the only scenario left is to find some multiples. Okay, so this is what I'm going to do. I'm going to go ahead and choose to get rid of the x's. I want to get rid of these. Okay, so in order to do that, I have to take those two coefficients and write down a few multiples of those coefficients. So 5, 10, 15, 20, 25, 30, and I can keep going on and on. Let's do some multiples of 6. 6, 12, 18, 24, 30, and 36. Well, what I want to find out is there any multiples that these two numbers have in common? So it looks like right away I can find one, and that would be 30. So my goal here is to try to get these x's to be a positive 30 and a negative 30. Okay, so that's exactly what I'm going to do here. So for this 5 to turn into a positive 30, I'm going to have to multiply it by 6. And on the other hand, down here, I want to get the opposite of a positive 30. I want a negative 30. So what do I have to multiply 6 by in order to get a negative 30? Well, that would be a negative 5. All right, so hopefully this is starting to make a little bit more sense now, and hopefully now we can actually start solving. So let's go ahead and distribute that to all of those three, and this to all those three. So let's see what we get at the top. We get 30x plus 24y equals, oh, let's see. Let me pull out my calculator real quick, guys, because I didn't have it next to me. So let's see what we get here. If you guys hold on for just 1 second, hopefully you guys can figure this out before I can. Okay, let's see. 6 times 8.48 equals 50.88. 50.88. All right, now my bottom one is a negative 30x minus 15y equals, let's see, let's do negative 5 times a 9.24, and I got a negative 46.20. Okay, if you guys want to go ahead and confirm that for me, but that is the answer that I got as of now. Okay, so let's go ahead and see what we could do with that information. So now we're going to go ahead and add our columns. Okay, so let's see, my 30x and negative 30x, those canceled, which was my goal, because now all I have to do is find my y. So 24 plus a negative 15y is now a 9y. And then I add both my 50.88 with my negative 46.2, and I should get 4.68. Finally, let's go ahead and divide that 9 to get a final answer of y equals, let's see, let's divide it out. I got 0.52, and because we are talking about a price, then this would be dollars. So my answer here for y is $0.52, or another way to say that is 52 cents. Okay, so that is my price of a fry. So some French fries would cost me 52 cents at this Steak and Shake. Okay, next part is to go ahead and substitute that 52 cents into one of the original equations. I'm going to go ahead and use the top one. Okay, so what do I get? I get 5x plus 4 times 0.52 equals 8.48. So this is 5x plus, let's multiply that on your calculator. I believe this is a 2.08, okay, equals 2.48. If I subtract these, oops, sorry, this is supposed to be an 8.48. If I subtract these, I get minus 2.08. Okay, so I get what? I get a 5x equals $6.40 so far. Now I just have to divide by 5. Okay, so let's go ahead and do that. This would be 6.40 divided by 5 for a total of 1.28. And yet again, we're talking about money here. So my price of triple burgers would be $1.28. Okay, so I now have officially figured out both of my answers. Okay, and okay, so that one would go there. This one would go here. Sorry, I didn't use those spaces, but you guys get the idea. Okay, so that was essentially a review of yesterday. It was actually a little bit more in depth than yesterday because we actually had to multiply both equations, when sometimes we more than likely usually have to just multiply one. But it's okay, we have different scenarios for different things. Okay, so what we're learning new today is again, everything ties in. So this is still very similar to what we learned yesterday, but we're just adding a little bit of a different scenario here. So let's go ahead and read the problem and see if we can figure this out. Some of the steps are going to be very similar. We're still going to define our variable. We're still going to write equations. We're still going to solve these equations. Okay? So let's go ahead and do number 2. So it says the algebra final consists of a total of 46 questions. Some test questions are worth 5 points, and some test questions are worth 3 points. There are a total of 150 possible points. Okay, so now it's asking how many 5-point questions are there? So how many 5-point questions are there? And how many 3-point questions are on the test? So right away, I can tell that that has to be my variables. So my variables are X are my 5-point questions, and Y are my 3-point questions. Now, notice that this is a little bit different than the ones we've been doing before. Before, we've been able to tell in two completely different sentences, we've been able to identify both equations. This is going to be a little bit harder, okay? Because we're talking about not only questions, but we're talking about points, okay? So, what I propose here is this. Let's go ahead and reread this, and you'll notice that there's a word here that we consistently use right before the numbers, okay? So it says, the algebra final consists of a total of 46 questions, okay? Some test questions are worth 5 points, and some are worth 3 points. There are a total of 150 points possible. So I saw 5 points, 3 points, and 150 points. Remember, in our equations, we've usually had 3 numbers. And right away here, I can identify that there's 3 numbers, 1, 2, 3 numbers that I can use. And they're all followed by this word here, points, points, points. So that is going to be my first equation. So I have 5 of the 5-point question. So, or rather, let me make this a little clearer. Each of the 5-point questions is worth just that, 5 points. So I do 5 times x plus 3 times y will be my total of points, which is 150. So this entire equation here is about points. Okay. Now, the only other number here is 46. And that 46 is followed by the word questions. So now what we have to do is, okay, if there's a total of 46 questions, okay, then what makes up the rest of that equation? Well, the only possibility of having, or the only type of questions that you will have on a final are either 5-point questions or 3-point questions. So that is it. That's your equation right there. You're either going to have the 5-point questions plus however many 3-point questions there are, and we know that 3-point questions are just called y in this scenario. Okay, so now we have both of our equations. So yet again, let's confirm. The first equation at the top, 5x plus 3y equals 150, that is completely just talking about points. Okay, the bottom equation is talking about questions. So 3-point questions and 5-point questions are the only things that make up the number of questions. Okay, so all of the x's and all of the y's, all of the x's and all of the y's will add up to be a total of 46 questions. Those are my two equations. Now I can go ahead and solve. All right. So again, we had the 3 choices. We're not going to try graphing. In this one, it is actually not too hard finding the answer through substitution. So what I'm going to actually go ahead and do is solve it using substitution, but you can go ahead and use elimination just like we have before as well. But just to make sure that you guys can see how you can solve it through substitution, I'm going to go ahead and solve it through substitution. Okay, so I'm going to ask myself, from those two equations, which one either already has x equals or y equals? Okay, well, none of them do. Both of them say x plus y, right? None of them say x equals or y equals. However, if I were to eliminate, so let me go ahead and rewrite that bottom equation so you guys can see it. What if I get rid of this y and send it to the other side? All I did was rewrite this equation, okay? But I now have a new form of that equation, which is x equals negative y plus 46. Okay, well, if I have that now, if I have that rewritten, then I'm literally saying, okay, x equals negative y plus 46. So why can't I just go ahead and substitute that in here? Well, I can. So let's go ahead and do that. So that would be 5 times negative y plus 46. And then let's keep writing the rest of it, which would be plus 3y equals 150. Okay, let's distribute here. So I get what? I get a negative 5y plus, I believe that's 230. Okay, so 230 plus 3y equals 150. I have two like terms here that I can combine. So this becomes a negative 2y plus 230. If I subtract my 230 from both sides, whoops, I would get a negative 2y equals a negative 80. If I divide by negative 2, I should get my final answer of y equals 40. So, how many 3-point questions will there be on the test? There will be 40 questions. So 40 3-point questions. Now let's go ahead and find out how many 3-point questions there would be. So all I have to do is substitute that back into one of my equations. Obviously, you guys can see here that this is the easier of the two equations, so I would suggest substituting it in there. So that's what I'm going to do. So I would get x plus 40 equals 46. Simple one-step equation. So I would get an answer of x equals, whoops, I'm sorry, not minus 46, minus 40, sorry. It's 40. So I would get an answer of x equals 6. And that would be my number of 5-point questions. And I won't go ahead and do it here, guys, but remember, you can always double check these answers. So in this particular test, there would be 6 5-point questions, and there would be 40 3-point questions, which already starts to make sense because 6 plus 40 is your 46, and that's exactly what they told us up here that there would be 46 questions. Okay? All right, guys, what I want you guys to try out now is number 3 on your own. So go ahead and give that a shot and see how well you do on that one. It's going to be very similar to the previous 2 problems, okay? Go ahead and give that a shot, and we'll come back and talk about it. All right, so let's go ahead and read the scenario, see how we can identify our variables and our equations. So it says Planters Nuts wants to mix peanuts and cashews for the holiday blend. Planters spend a total of $300 on peanuts that cost $3 per pound and cashews that cost $8. Okay, they wanted their mixture to be 60 pounds. How many pounds of each variety should be mixed? Okay, so we can actually start seeing down here already that what we're going to be talking about are our x and our y. Okay, so let's go ahead and do that. So first thing we need to figure out are my x, which is the number of, oh my god. Sorry guys. I swear I'll get a new laptop one of these days. We won't have so many issues. Okay. Here we go. Let's go. Okay. So again, let's define our variables. We have x equals the pounds of peanuts and y equals the pounds of cashews. Okay. All right. So again, just like before, let's go ahead and see if we can identify which 3 numbers should be in the same equation. So let's look at clues around the numbers to verify if we can find what units they're given. So the first number I see here is 300, and it's dollars. Okay. This right here is $3. This is $8, and then I have 60 pounds. As you guys can notice, those are 4 numbers that were given in this equation, in this problem, and 3 of them have something that they all have in common, and that would be money. Okay, $300, $3, and $8. So let's go ahead and make an equation using that information. So let's go ahead and make our first equation. So $3 per pound of peanuts and $8 per pound of cashews. So it's going to be 3x plus 8y for a total of how much money? $300. Okay. The only other number that kind of stood out there all by itself is this one, 60, but that one has a unit of pounds. Okay, well, we're either going to have pounds of peanuts or pounds of cashews, right? So the entire container is going to have both. So if you mix the pounds of peanuts, which is exactly what X is, and then if you mix the pounds of cashews, which is exactly what Y is, you should have X plus Y, and both of those make up the total amount of poundage, which in this case is 60. So very similar to problem number 2 on the previous page. So now we can solve either using substitution or elimination. Again, we've gotten a lot of practice with elimination, so what I want to do now is actually continue using substitution. So that's what I'm going to do. Which one of those two equations looks easy to solve for either x or y? The bottom one looks pretty good, okay? So I'm going to go ahead and use that one. So it'd be x plus y equals 60, okay? In the previous problem, I actually solved for y first. I think what I'm sorry, I solved for x. I got rid of the y. Now let's actually get rid of the x. It doesn't matter. You can get rid of the x or the y. I'm just going to get rid of the x now. Okay, so I'm going to get y equals negative x plus 60. Again, this equation is just a rewritten form of that one. But now I know that y is equal to negative x plus 60, so I'm going to go ahead and substitute that right in there. So let's try it out. So we get 3x plus 8 times negative, oops, let me rewrite this whole part right here. 8 times negative x plus 60 equals 300. Distribute my 8. 3x minus 8x plus 480 equals 300. I have two like terms here. I can combine those to get negative 5x. I have to get the x by itself, so let's get rid of that 480 before I get rid of that 5. So I get negative 5x equals negative 180 divided finally by negative 5. So we get a final answer for x of x equals not 90. This would actually be, oh my god, I'm totally having a brain fart here. That would be 36? Yeah, 36. Sorry guys, had a brain fart there for a second. Alright, so x equals 36. We know x equals the pounds of peanuts. So I'm going to go ahead and write that 36 in there. Okay? Alright, so that's cool and all, but now I need to find my y. So what I'm going to do is substitute this in for my x, and I'm going to go ahead and substitute it into this equation. Let's go ahead and do that. I'm going to make another little wall here. So let's see. This is 36 plus y equals 60. Subtract my 36 to get a final answer for y of y equals 24. So y equals 24, which is my pounds of cashews. And already you guys can start to tell that makes sense. Look, 36 plus 24, what does that add up to? That adds up to 60. And we were talking about pounds in this problem. And look at that. That's exactly how much pounds we said we were going to put in the container. So we are on the right track. All right, guys. I think we had some good practice with that. So why don't you guys go ahead and try number 4, and then we will come back to finish up on the next page. All right, so I'm actually going to run through this one pretty quick since you guys have already given it a shot, and because it's very similar to the previous problems, and I really want to go ahead and continue on with this video with the next page because I feel like there's a little bit more of a challenge problem on the next page as well as a little bit of review. So I'm going to define my variables here real quick. So let's go ahead and read the scenario. It says last year there was 330 people at Addison Trails Winter Play. The admission price was $3 for adults and $1 for students. Addison Trail raised $650 for the play. how many adults and how many students attended the winter play. So X equals the number of adults that went to the play, and Y equals the number of students, right? And usually, guys, the last sentence or the last question will actually give you what the variable should be, okay? Adults and students, okay? All right, now let's identify what our first equation should look like and what our second equation should look like. And again, let's start to think about, or let's actually look at the units of those numbers to verify which ones should go together. So, first number I have here are 330 people, then $3, $1, and $650, okay? And as you guys can remember, we need 3 numbers at least to make up that equation. And which one of these 4, which 3 out of the 4 have the same units? Well, I'm sure you guessed it. These 3 have the same units. They all talk about dollars. So in order to write the equation, let's go ahead and use our variables. So $3 for adult tickets. So adults was X, so this is going to be 3X plus $1 for students, so 1Y equals a total amount of $650. That is my first equation because all 3 of those numbers included the symbol of dollars, or we were talking about money here. The only other number that we didn't use was this one, and that one it's talking about people, okay? So that's a total of 330 people. Well, what are the only types of people that were at this play? Adults and students. So if I add up the sales of adults plus students, I should have a total of 330 people. And look at that, I already have my equation, okay? And just to make sure it's clear, guys, this one right here, that 1y, I didn't have to put the 1y, I could just leave it as y, just to make sure that you guys are on the same boat, okay? So again, I can go ahead and use substitution or elimination, all right? I am actually going to use elimination on this one. And the reason why is for 2 reasons. Because in the past 2 problems, we did substitution. And because I can see something that would cancel if I just multiplied it by a -1. And actually, I just figured out a third reason. A third reason is because most of you guys probably tried substitution. Okay? And if you did, this is a nice opportunity for me to try elimination, which is a completely different process, and still show you and prove to you that it doesn't matter what method you try. Okay? So this is what I'm going to go ahead and do. I can turn this positive y up here into the opposite of that positive y by multiplying this whole thing by a -1. So let's go ahead and see what happens when I do that. Okay? So what do I get? I get a -3x, a minus y, and a -650. The bottom one, I don't even have to change. I'm going to keep it as x plus y equals 330. I can now add my columns. Let me scroll down a little bit here. Okay, so what do I get? Well, -3x plus 1x would be a -2x. These now cancel, and then I would get a -320. Final step here, divide by -2. A negative divided by a negative is a positive, so that is a positive 160. And what does that x stand for? X stands for the amount of adults that attended. So the number of adults that attended were 160. And now I can once again go ahead and substitute that number back into one of my original equations. I usually pick the easiest one, but just to prove to you guys that it doesn't matter which one you pick, I'm going to pick the harder one this time. So I'm going to substitute it into the top equation. So let's see what we get here. So that would be 3 times 160 plus y equals 650. Okay, that would be let's see, 3 times 160, that would be 300 and, okay, so 480, okay, plus y equals 650, subtract my 480 for a final answer on my y of 170, okay? So if my y is 170, that means the number of students that attended was 170. And look at that. If I add 160 plus 170, what do I get? 330. And that's exactly the number of people who attended the play. Okay? All right. So again, if you use substitution, you should have gotten the same answer. I used elimination in this particular problem, but it honestly does not matter. Okay. All right. Let's go ahead and look at this challenge problem. So if you want, I'm going to actually go ahead and give you a chance to try this out on your own without even going through it with me. Okay, so maybe you can figure it out on your own, which would be great. Okay, so I'm going to give you guys about, well, take as many time as you need. Actually, you guys can pause the video, obviously. So go ahead and try out number 5. See if you can figure out the 2 equations here. You're still going to set up a system of equations. But let's see if you can figure it out. So go ahead and pause the video and try it out. All right, guys, let's go ahead and talk about problem number 5. So this one is actually very, very simple and very, very basic if you let it be, okay? If you overthink it, then you might make a mistake here. But if you just kind of go along with what it says and do what it says, then you should have no problems. But the biggest thing here is to understand a few things, to understand what it means to be a sum and what it means to be a difference, okay? So here we go with my pen. So don't mind this blue blob here on the side, guys. I'm just trying to make the pen work. Okay, so it says, what is the sum of 2 numbers? And then we talk about a difference as well. Okay, so it says the sum of 2 numbers. Well, let's first talk about what the sum means. A sum is a fancy word to say adding. Okay, so if I have 2 numbers, which we're going to go ahead and call x and y, the sum of those 2 numbers, x and y, will be 47. So I can write that down. X plus y equals 47. That's my first equation. Okay, and this is probably going to erase on you, so go ahead and, yep, go ahead and write it down. So again, I'm not sure why my pen or my laptop do this, but they act up. So I'm sorry about that, guys. I really do need to or to actually record videos without having issues like this. I'm not exactly sure why this happens. It might even be something on the program that I'm just not sure about. Okay, so 2 numbers, x and y, so x plus y equals 47. Difference means subtraction. So the other equation would be x minus y equals 15. Okay, and I realize that's going to erase for some reason. Okay, let me try something out before we move on, guys. Let's see if this works. If you are watching this, go ahead and fast forward until I start writing again. Sorry about that, guys. Okay, let's see if this works. Sum and difference. So sum is x plus y equals 47. Difference is x minus y equals 15. Whew, awesome. Okay, now I can write. For some reason, it's not working earlier, or it wasn't working earlier, but now it's working. Okay, so I set up my 2 equations. Sum just means adding. Difference just means subtraction. So that's it. Those are my 2 equations. Simple as that. Don't overthink it. Now you have to decide what method you want to use. And there's one clear method here that you should definitely try to use. And hopefully you can see why. Okay, the method you need to try to use here is elimination. Why would you do that, Mr. Dorado? Well, look at this. If I add those right away, the y's are going to cancel. Okay, so I'll just have 2x equals 47 plus 15, that is a 62, if I'm not mistaken. Wow, why am I dividing by 6? Divided by 2. So you're going to divide both sides by 2. And then you're going to get x equals 31. All right, my x equals 31. Let's go ahead and figure out my y. So I'm going to substitute that back into one of my equations. I'm going to use the top one. So 31 plus y equals 47. Subtract the 31. You get y equals 16. And that is my answer for here. So 31 and 16. And because these numbers are really simple, why don't we actually test those two out? So let's test out the first equation. 31 plus 16 equals 47. If this is true, then we should get a true statement here. So what's 31 plus 16? Well, that's 47. So yep, checked out. Let's try the second one. X minus y equals 15. So 31 minus 16, sorry. 31 minus 16 equals 15. Well, 31 minus 16 is equal to 15. So those two check out. So because both of them check out, then this is complete. We have officially finished that problem. Okay? Number 6 is exactly the same. So now that you know that, go ahead and let's try that one out. All right. So the sum of two numbers of x and y is 11. So x plus y equals 11. And then the difference is 5. So the difference of those two same numbers is 5. So I have my two equations again. Again, which method probably looks like the best method you be using here? Definitely elimination, because those y's cancel out. You get 2x equals 16 divided by 2. X equals 8. Okay, substitute that back into one of the equations. I'm going to just use the top one. So x plus y equals 11. Subtract 8. You get y equals 3. So my y equals 3. Let's verify, make sure that's true. Let's try both scenarios out. So let's try out both of my equations. So x plus y equals 11. If I substitute in my numbers, I get 8 plus 3 equals 11. And is that true? Is 11 equal to 11? Yes, it is. Let's try out the bottom one. X minus y equals 5. So if I substitute my numbers in there, it's 8 minus 3 equals 5. And sure enough, 5 does equal 5. So that is correct. Okay. Whew. Kind of rushed through that one, but I hope that made a little bit more sense. If not, make sure you look at the previous problem. That should help you out. Okay. All right. I think I'm actually going to stop the video here. There are two of these mixed review problems, which is essentially using substitution or elimination, whatever your choice. Okay. But these are essentially review problems. So this is back from 5.2 and I'm sorry, actually not 5.2, 5.3 and 5.4. So if you guys have any questions on either 7 or 8, you can go ahead and look at both of those videos. I will give you my 2 cents right here on these problems. I would more than likely do substitution here. And I would more than likely use elimination. This one. So that's my little, not eliminations, just elimination. Okay. All right, I would probably use elimination on that one. I'm sure you can probably see why as of this point. If not, just know that that's what I would use. So if you want, go back and watch some of those previous videos. All right, guys, I'm going to go ahead and end the video there. And yeah, I think this was it for this unit, if I'm not mistaken. There might be one more I have to record. But besides that, I think we are all set for Unit 5. So if you have any more questions on setting up a system of equations, solving a system of equations, or solving a system of inequalities, make sure you watch the first few videos of this unit. Okay, guys? All right, well, I'm going to go ahead and end it there. This one ran a little bit longer than I wanted to, but it's okay. at least we got most of the material out there. Okay, so go ahead and stop the video at this time, and I will talk to you guys soon. All right, guys, take care. Good luck.